Hey guys, we still keep doing quadratic equations, and here there's like weird topic, and actually weird because of have a look at the examples we have right now. So we have definitely a bit weird quadratic and biquadratic equations. So for example, have a look at number 5, looks like fractional, so number 6 is also fractional, and number 7 is, wow, power 4. All right, here it's time to struggle with these sort of questions. That's actually higher tier definitely. So I'll teach you how to do that. All right, so let's first undertake the first one. So you have 2x over 3x plus 1 and 1 over x plus 2. So, actually many teachers don't tell you that you need to start from like conditions, like specific conditions for the bottom parts. Obviously you have, when you have fractions, and in the bottom part, like here, you have some expressions that involves x's. So in this case, you clearly see that for some x, there might be the case when your denominator might be 0. So in order to, of course, you can check your solutions on the final stage. However, I recommend immediately exclude those x's which lead to have your bottom part or denominators to be 0. So what I'm saying about? I'm saying that simply 3x plus 1 is not equal to 0, as well x plus 2 also should be equal to 0. So from where you can exclude solutions of these mini equations. Alright, so x from the first one is not equal to negative 1 over 3, and x also shouldn't be negative 2. So just bear in mind, or it's better to write down immediately when you see fractional equations. So you also might be, might need that sort of specific conditions that restricted your solutions from the whole range, and that might be found in surds. We have square roots, but we actually right now have to deal with fractions and with denominators. So we're going to say that if we have, for example, solution x equals negative 2, we just simply exclude that. All right, now let's try to solve that. Because it's fractional one, and you just keep remember how we did it during linear equation, how we solved that. We just use a crisscross multiplication. So you take in the bottom part, multiply by the top on the right hand side, and the same you do with the bottom on the right side and multiply by 2x on the left side. So finally you'll get the following. 2x times x plus 2 will be equal to 3x plus 1 times 1, or simply we keep that expression unchanged. Okay, so now let's simplify. You'll have 2x squared plus 4x, and also I just transferred right side to the left side. Minus 3x minus 1, so don't forget changing the signs. From where we have the following. 2x squared minus, so plus x, and minus 1 finally. Okay, and now it's time to solve that. Right now you see this is quadratic equation. So right now we resolve that fraction and came to quadratic equations. Okay, so which method to use? So you can try to factorize, or you can try to use the quadratic formula. So for example, here I'll try to use factorization, and I simply make a sketch or a sample of my possible factors. So obviously they should be linear, but because the leading coefficient is 2, so I put 2x plus a and times just normally x plus b. Why I've taken 2x in the very beginning? Because I know if I start expanding that brackets, I'll get 2x times x, which is 2x squared, and I'll definitely need to have this term. So that's why I'll just have a little change to what previously we did before. Okay, so now just simply expand it, and I'll use comparison method here. So 2x squared plus 2xb plus ax and plus ab equals to 0. So from where I can even more simplify and say that I'll get x times 2b plus a and plus ab in the end. Alright, so now let's compare with what I have as the original expression. I had 2x squared, okay, let's coincide and match, plus x and minus 1. Okay, so looks like AB should be equal to -1. So that's why right now I'm setting up what I have here, and I have the following steps. I have comparison AB is 1, and also 2b plus a should be equal to coefficient before x, that's simply 1. Okay, so a times b is 1, and 2b plus a is also 1. So what's the possible solution? So probably, let's see, if b is 1 over 2, and a is 1. No, we can't get that. So we need to guess actually what stays for a and what stays for b. So if a and b is 1, that doesn't work. Oh, okay, I see my fault. So actually the product is -1. Yeah, I messed up. All right, so we have AB equals to -1. So looks like B is just 1 and A is just -1. So because the product will give us -1 and 2B plus A should be 1. So 2 minus 1 is 1. Okay, so that's solutions. And we just come back to our form, which is here, and simply do the following. We just need to rechange our A and B. Instead of plug here, instead of A and B, we'll need to plug 1 and -1. So final expanded form will be 2x minus 1 and times b, x plus b, so x plus 1. That means we have 0. From where x1 is 1 over 2 and x2 is -1. So maybe you'll see that this way is pretty long. However, so you need to be able to do that. And if you're really on fast track, or you want to be on a fast track, so you need to use quadratic formula, which is faster, definitely. All right, so I just demonstrate for for the reasons so that you need to be able to do that, to do factorization. And finally we found solutions. So let's check what we have according to our conditions. Now we have solutions and they meet our criterion about non-equality to -1 over 3 and -2. So they are both solutions, so we include them. That's solution. All right, let's get to the next one. So exercise 6 here. Okay, so we have two fractions and sum of them are equal to 4. So again, we need to say that x plus 1 should be 0 and x is not 0. So from where we can find that x is not -1 and x is not 0. So that's our conditions, and later on we need to check our solutions. So next one, what we're gonna do, there are two ways actually you can come to the common denominator, or you just simply can multiply by x and x plus 1. Remember we did it before, like when we try to solve linear equations. So I just try to come up with the common denominator. So the common denominator here is x and x plus 1. So x goes here, so like sort of extra factor, and x plus 1 goes here, is extra factor to 4. So I'll get 6x and plus 4x plus 4 on the top. So I also transfer 4 here to the left hand side, and I can do the following. So instead of 4, I simply can write that it's 4 times denominator So x and x, so x and x plus 1, and over x plus 1. Why I did that? Because I want to have the same denominator, just to add up the top parts of the fractions. And now, because I transferred 4 to the left hand side, I'll get 0 on the right hand side. Okay, so what we have, we just need to simplify similar terms and we'll get the following. So we get the following fraction. So we'll get 10x plus 4, and then we need to subtract because the minus here. So 4x times x is 4x squared, and minus goes also here, so it's 4x times 1 minus 4x. So the bottom part stays the same, and now we equate to 0. Now, let's see. Actually, we have the top part and the bottom part of the fraction. So please, guys, tell me if you have sort of fraction a over b equals 0. We definitely know that b is non-zero, while a should be 0, and otherwise your fraction is not 0. So in this case, we have the top part of the fraction, which is 10x plus 4 minus 4x squared minus 4x. So I just simply simplify that, and I'll get the following: 4x squared with negative sign, and 10x minus 4x is 6x. So I add 6x and add 4. The result is 0 because the top part should be 0. Okay, so now we need to solve that. In this case, what I can do, I can even more simplify. I just divide by -2, or I can factorize -2, doesn't matter. Let's do factorization instead of division. Maybe it works better. So I just factorize -2, and in the brackets I'll get 2x squared minus 3x and minus 2, which is 0. And now I know, according to the null factors theorem, or law, we know that -2 is never be 0, and only expression in the brackets be 0 now. So I'll get 2x squared minus 3x minus 2 equal to 0, and now we need to solve that. Okay, in this case I will use discriminant. So quadratic formula in play. Quadratic formula. So let's do that, and I just simply write the formula for how to find coefficients. So not coefficients, x solutions. So the formula works like minus b plus minus square root of b squared minus 4ac. I just remind you guys, and over 2a. So where to take or to get b, a, c values, just remember general equation in standard form, general quadratic equations. So you just compare it, and you establish values for a is 2, b is -3, and c is -2. And simply you just plug in to the quadratic formula all the values for a, b, and c. So we got the following: -3 is 3, that's b, plus minus square root of b squared is 9, minus 4ac, so plus, because -2 also, 4 times 2 and times 2, 4 times 4 is 16. Okay, good discriminant, over 2a over 4. From where you can get the following: 3 plus minus 9 plus 16, 25, so it's 5, and over 4. So looks like we have two values: x1, 3 plus 5, 8 over 4 is 2, and x2 is 3 minus 5, it's minus 2, and over 4 minus 1 over 2. So solutions, perfect. Now we're going to compare with what we had before. So take these solutions here and just check with restricted values that actually x cannot intake. So no problems, because here is -1 and 0. However, what we've done here is just 2 and -1 over 2. They're completely different. So that's solution. That's solution to our equation x(6). Okay, so one more time, just try to check yourself, guys. All right, so and we move into the next one. So it's very interesting because you have x4 and here is x squared. So right now, probably you thinking about what sort of equation, yeah, power 4 looks like it's more complicated, but actually it's not. So let's see how we can do here. So actually, this sort of biquadratic equation, why by? Because we have x to the power 4, which is actually x squared and squared again. So let's see how it works. Normally you don't need to panic. You just simply transfer everything to the left hand side and trying to see the structure. So you're just simply saying that, what if I have t equals x squared? Alright, in this case, instead of x4, you just simply have t squared and squared, which is t4. Oops. X squared and x squared, so x squared and squared is simply t squared. Is t squared now. Okay, so instead of x squared, we'll get just t, and here is 5. So what you can say? That here and here, just normal quadratic and linear terms. So this equation now becomes quadratic. So in terms of t variable, equation is quadratic. So we have quadratic equation. And you already know how to solve that. So instead of t, we set up for t is x squared. So what are we going to say? That t should be more equal than 0 because x squared never be negative and the minimum value is 0. So keep in mind, and this sort of conditions that you need to check. For example, if you'll get negative value for t, you just need to get rid of that because it doesn't satisfy conditions. Or you can like check later, but I think that the simplest way is just to establish condition immediately. All right, so now we try to solve this equation in terms of t. Let's do that. I'll use factorization, so I just simply say the product of AB should be -5, so it looks like it's -4 and let's say 1, and the sum, so that's the product, right? Oh, -5 and 1, which is the result of -5, and from there you need to know that if you add them, you should get -4. So it looks like our A and B is -5 and 1. So I can immediately use factorized form or write that in factorized way. And you can also check yourself. So if you expand the brackets, you need to come back to that. All right, so we've done that. Now we know that one t value, t1 is 5, and that's good because it's positive. But the second value is -1, so we just simply discard that value due to conditions t more equal than 0. Just look up here. All right, so we just discard that, and that's why we left with t1 equals 5. But don't forget, like, you don't need to solve because your final solution needs to be given in terms of x. So that's why just remember that t is x squared, from where you can simply say that x squared is 5 and 2 solutions here, because that is a quadratic equation in the simplest form. So the simplest form of quadratic equation. So simply that, taking that x is equal to plus minus square root of 5, and that's 2 solutions here. All right, so just one more time, watch the methods. So you heard the term biquadratic equation. So for most students it might be a new one, however you might be struggling with this sort of question. Okay, so hope you enjoy. That was I think very useful videos for advanced students, for definitely higher tier. Don't forget to subscribe. If you required like new video at like let's say higher level, just give some comments and I'll definitely create that. Okay, so don't forget to subscribe and just press the bell button to be notified about my latest updates. That was Daniel Dallas, and good luck to everyone.